Hello and welcome to this question on trigonometric problems in context. So this is a kind of typical question where you have to take the trigonometric stuff that we've learned and apply it to a real life situation. So if we go through it bit by bit, the first bit here says express 65 cosine theta minus 20 sine theta in the form of r cos theta plus alpha, where r is more than 0 and alpha is between 0 and pi over 2. And we need to give our values of r and alpha to 4 decimal places. So this here isn't really any modeling yet. This is just basic stuff that we've been doing in previous topics. So let's start off with this. And what I've done here is I've just written out all the working, and we're going to go through it step by step. So like we've already done, I would expand my r cos theta plus alpha, so it looks like this. And then I would expand the brackets to get this. This is the same thing we've been doing before. And I'm going to equate the 65 cos theta minus 20 sine theta to this expanded form. And that means that this 65 here is equivalent to r cos alpha. That's what I've written here. And this 20 is equivalent to this r sine alpha. 20 equals r sine alpha, so I've written that down. So we've now got these two equations, both with r and alpha in, so we can now basically have simultaneous equations. So to find alpha, we do this one divided by this one here. R sine alpha over r cos alpha gives us tan alpha, and the 20 over 65 gives this. So then we just do inverse tan to find out what alpha is. And then for r, we just do 20 squared plus 65 squared equals the r squared, and we square root it to find r. And that's it. So now we've basically now rewritten all of this stuff as one single function, which looks a bit long and complicated because everything's at 4 decimal places, but it's just basically 68 cos theta equals theta plus 0.3, roughly. Awesome. So that's the basic bit done. Now we can go back up to our question here and read what it says. So it says that a city wants to build a large circular wheel as a torus attraction. The height of a torus on the circular wheel is modeled by the equation h equals 70 minus 65 cos 0.2t plus 20 sine 0.2t. So as soon as you read this, you want to kind of notice that this bit here is basically the same as this bit here, except we have 0.2t rather than theta. And so that means that instead of writing all of this stuff, we can apply that idea to this bit here, and we can write it using the stuff that we just found. But again, rather than writing theta, we'll put 0.2t. Okay, so then it says, well, the question is, it then says, where h is the height of the torus above the ground in meters, t is the number of minutes after boarding, so how many minutes it's being going around for, and the angles are given in radians. So the first part of the question is to find the maximum height of the wheel. So if we sketch it, here we've got a wheel, we need to find the maximum height. We want to find h when the person is at the very, very top. That's for part B. Part C is we need to find the time for one complete revolution. So basically, how long does it take to get all the way around the wheel? So either from top all the way around the top, or bottom all the way around to the bottom, or basically anywhere to the same point. And D, we want to find the number of minutes the torus will be over 100 meters above the ground in each revolution. So the number of minutes the torus is going to be above 100 meters above the ground. So we don't know where 100 meters is because we don't know how tall this thing is. But imagine that 100 meters was here, and this was 100 meters on this side. So the number of minutes that is over 100 meters is basically the number of minutes it takes to go from here all the way around to here. So I can imagine it's traveling anti-clockwise. The time it takes to get from this point all the way around to this point, that will be the time that he's above 100 meters. So that's a glimpse of the questions. So let's start off with trying to find the maximum height of the wheel. So to find the maximum height of the wheel, the first thing we want to do really is write out our function using this thing that we just found. So I've done h equals 70 minus 68 cos 0.2t plus 0.2985. So I've replaced all this kind of complicated stuff with this much easier form, because we just found out that it's exactly the same thing. Now, I want to think about how to maximize each term. So 70 is just 70, there's nothing we can do with that. But what about this stuff? Well, if I'm doing 70, take away this, I want this to be a negative number, basically. It might help a little bit if I put square brackets down here. Yeah, I basically want this to be as big a negative number as possible. Because when I do 70, take away a negative number, that's going to give me a bigger number, like the maximum height. So to make this as big a negative number as possible, I would think, what's the most negative a cos function can be? And the answer is just minus 1. Yeah, that's the most negative a cos function can ever go. It just fluctuates between minus 1, positive 1, minus 1, positive 1. So considering the 68 there, the most negative this entire thing can be is, well, 68 times minus 1, so negative 68. Which means find the maximum height could be 70, take away negative 68, or 70 add 68, which is 138 meters. Yeah, so that is the maximum height of the wheel. That's as tall as it can ever be. So if we scroll back up, part C said calculate the time for one complete revolution. So the time it takes to go all the way around. So if we think about that, to find the time of one revolution, we really need to find 2 consecutive times when the wheel is at the same point, like when it's at the maximum height, for example. Because if the wheel is like this, and if we knew the time it was at the very top, say that was t1, and then we went all the way around, and then we found out the next time that it was at the very top, say t2, the difference between those times must have been how long it takes to get all the way around. And the reason I'm using the maximum is because we just said a moment ago that when it's at the very top, our cos function will equal minus 1. So kind of, I know what the cos function is going to be, so that's the easiest one to use. So basically, this cos function would have to equal minus 1 to give us that maximum height. So if I sketch out a cos function, the 2 places where the cos graph is going to equal minus 1 is down here and down here. Because remember, on the y-axis, this is minus 1, this is positive 1. So basically, so if we do, so our solutions really are pi and 3 pi. So the 0.2t plus 0.2985 is either going to equal pi, like I've written here, or it's all going to equal 3 pi, like I've written here. And then we can just rearrange these to find t. So in this case, I would do pi, take away this bit, and then divide it by the 0.2, which is what I've done. And that gives me a time of 15.559 minutes. Or for this other one, same thing. I take away this bit, divide by 0.2, gives me a time of 46, or nearly 47 minutes. So to find the time for the whole oscillation, going all the way around, I just do t2 minus t1, and the difference between those times is 31.4 minutes. So that there is how long it takes to go all the way around. Nice. So last one then, if you scroll all the way back up, we now need to find the number of minutes the tourist will be over 100 meters above the ground in each revolution. So like we were saying at the beginning, the time that he spends, once he's hit 100 meters, how long does he spend above 100 meters, like this whole bit, before he drops below it again? So really, we need to find this time, where he gets to 100 meters, and this time, when he drops below 100 meters. So basically, so to find the time above 100 meters, we need to find the 2 times when they're at 100 meters. So to find those 2 times, we need to set our height h to 100. So we're saying that our function, our 70 minus 68 cos 0.2t plus 0.2985, we set that equal to a height of 100. So then rearranging, moving the 100 to the left and this function to the right, we get this. Dividing both sides by 68, we get this. And then I would sort of like sketch a little graph, sketch a little cos graph. And I know that if I'm looking for this, minus 30 over 68 is around about minus a half. So I want to find my angle t when, well, the time, but I want to find the angle in here when the function is around minus a half, so around about here, which is going to give me a solution here and a solution here. So when I put this in the calculator, when I do inverse cos of minus 30 over 68, I get this solution, which would be this one. But then to find this solution here, I have to do 2 pi minus that value. So 2 pi minus this, and that gives me this solution. But remember that these are solutions, well, are equal to 0.2t plus 0.2985. So you then have to equate them to that, and we have to rearrange them to find t1. So I've solved this one for t, and this one to find t2. So I've now got 2 times, 8.5 minutes and nearly 20 minutes. So to find the time above 100 meters, I take one from the other, and that gives me the time that they spend above 100 meters. So anyway, I hope that's made sense. This is a fairly complicated one. I think this is kind of one of the longest, most complicated ones that I've seen on this topic. It's mainly difficult because, well, one, it's just so long, it takes ages to go through all these steps. And two, you really have to conceptually understand what's going on to do these parts. I know I kind of glanced over a lot of the basic maths in here. A lot of the like rearranging equations and finding this formula, like I did that quite quick because we've covered all that stuff in previous videos. So if there's anything there that you didn't quite make sense, have a look at some previous videos to cover how to do those basics. But in this video, I just kind of wanted to go over the main concepts of how to do this more complicated question. Anyway though, if you have any questions, let us know down in the FAQ. And otherwise, I'll see you in the next video. Thanks.